Hello students, in this video we are going to evaluate some definite integrals using Cauchy Residue Theorem in complex analysis. For that we are in need of some basic conditions. In this video we are going to see how to evaluate type 1 integrals. Type 1 integrals are of the form integral 0 to 2 pi function of cos theta and sin theta d theta. And here we are going to make some assumptions. We have to take z as e power I theta, differentiating both sides with respect to the corresponding variables. Dz is equal to e power I theta into I theta we have to differentiate, that is I into d theta. Keep d theta in one side, bring these two terms to the other side. So d theta is by e power I theta into I. E power I theta already we took as z. So d theta is equal to dz by z into I. So we have to start with z is e power I theta, d theta as dz by iz, and cos theta is equal to z plus z inverse by 2, sin theta is equal to z minus z inverse by 2. So these two you have to study, and this one. And here the limits are from 0 to 2 pi. In the problem they will give, we will convert everything to a curve C, where C is a unit circle, mod z equal to 1. So you have to memorize z is equal to e power I theta number 1, dz is equal to d theta is equal to dz by zi, then cos theta formula, sin theta formula, and C is a curve, mod z equal to 1. The first problem what we are going to do is, we are going to evaluate an integral 0 to 2 pi d theta by 4 plus 5 sin theta. So what is the assumption we have to start with? Let z is equal to e power I theta, then d theta is equal to dz by I into z, and C is a curve, C is a unit circle. It is a circle with center 0 and radius 1. So we are going to substitute everything here. Therefore 0 to 2 pi d theta by 5 plus 4 into sin theta is equal to integral over C dz by iz for d theta by 5 plus 4 into sin theta can be replaced by z minus z inverse by 2i. 2i we can take the LCM, integral over C dz by iz. When we take 2i as the LCM, 5 into 2 is 10i plus 4 we are multiplying inside, 4z minus 4 into z inverse by 2i. This I and this I we can cancel. So we are getting integral over C dz by z into 10i plus 4z minus 4z inverse. We can multiply z inside. So dz and anything else by 2 we have no, that we can take to the numerator. So 2z by z I am multiplying inside. So 10iz plus 4z squared minus 4 into z inverse is 1. So 4 into 1. All the terms are having 2 common, so I can take 2 outside. Integral over C 2 dz by 2 I am taking outside and arranging z square term, z term and constant term in order. So 2z squared, and here 5iz, and here it is minus 2. I can cancel this 2. So finally what I have is integral over C dz by 2z squared plus 5iz minus 2. Now we are going to proceed with Cauchy Residue Theorem. For that, first what we have to do, we have to find the poles. So for how to find the poles, taking the denominator term equal to 0 and find the values for z. So we have 2z squared plus 5iz minus 2 equal to 0. Directly we are not able to factorize this. So for that we are going to use the formula method. Formula method, if you are going to use, means a equal to 2, b equal to 5i, and c equal to minus 2. So z is equal to minus b. One thing I didn't stress, before going into the formula method, we have to make this coefficient as 1. Z square coefficient should be equal to 1. So how to make it After that only we can proceed. How to make it? Taking 2 as common, integral over c dz by 2 I am taking outside. So this term will become z squared. Here we don't have 2. So taking 2 in the numerator, we will get 2 in the denominator. 5 by 2 I z minus 2 we have taken out. So it is minus 1. For this equation only, we are going to find the poles. So what for this polynomial only, we are going to find the poles. So z squared plus 5 by 2 I z minus 1. So z squared minus 5 by 2 I z minus 1. This is plus 5 by 2 I z is plus minus 1 equal to 0. For this, a is 1, b is equal to 5 by 2 I, and c is equal to minus 1. So z is equal to minus b, that is minus 5 by 2 I, plus or minus root of b squared, that is 5 by 2 I the whole squared, minus 4 into a into c. C value is negative sign, so it will become plus by 2 into 1, 2. So minus 5 by 2 I plus or minus root of 5 by 2 the whole square means 25 by 4. I squared is minus, so this term in minus sign, plus 4 by 2. Taking 4 as the LCM, and we are having minus 25, 4 into 4 plus 16 by 4 by 2, which is equal to minus 5 by 2 I plus or minus minus 25 plus 16, it is minus 9 by 4 within root by 2. Minus sign when we have in the square root, when it come out, it is I, because already we know that root of minus 1 is I. Okay, so we can write this as minus 5 by 2 I plus or minus I into root of 9 by 4 can be written as 3 by 2 outside the root by 2. All are having 2 now. Minus 5 by 2 I plus or minus I 3 by 2 by 2. So which can be written as this, taking the LCM, minus 5 by 2 I plus 3I by 2 by 2. Number 1, minus 5 by 2I minus 3I by 2 by 2. So adding these two, it is minus 2. So when we simplify, this is minus 2I by 2 by 2. So after cancellation, this is minus I by 2, number 1. And this is minus 8I by 2 by 2. So it is minus 2I. See, this is, both are in the denominator. We can combine this as minus 8I by 4. So when we cancel, it is minus 2I. Similarly, this one, both 2's are in the denominator. So minus 2I by 4. So 2 will come in the denominator. So we are getting the poles minus I by 2, number 1. And this is minus 2I, number 2. So these are the poles. Before going into Cauchy residue theorem, we have to make sure which pole lies inside the circle and which lies outside the circle. This is actually the point 0, minus 1 by 2. And this is a point 0, minus 2. We have a unit circle. Unit circle means up to 1. This obviously this point lies outside. 0, minus 2 means up to 1 only we can take the points lying inside the circle. So this lies outside. So no need to find the residue for this. Only for this pole we have to find the residue. After that we have to use Cauchy residue theorem. So we are going to apply. We are going to find residue of f of z at the pole minus I by 2. And this is the first formula we have. Limit z tends to a, z plus a into f of z. That formula we are going to use. So a is minus I by 2. So z tends to minus I by 2, z plus I by 2 into f of z. What is our f of z here? So this is my f of z, leaving dz 1 by 2 into this term, right? So 1 by 2 into, and this term only we got the two factors as minus I by 2 and minus 2I. So we are going to write in as factors. So z minus of minus I by 2, that is z plus I by 2, then z minus of minus 2I, that is z plus 2I. These two will get cancelled, and at last we have limit z tends to minus I by 2, 1 by 2 into z plus 2I. So what value we have to substitute for z? Minus I by 2. So 1 by 2 into minus I by 2 plus 2I. So after taking the LCM, we are getting 2 as the LCM, no? So minus I plus 4I by 2, 2 we can cancel. Minus I plus 4I is 3I. So this part is 1 by 3I. So residue is 1 by 3I. And finally, for the integral, no, what is the formula? We have 2 pi I into sum of the residues. 2 pi I into, what is the residue? Only one residue we got, that is 1 by 3I. So I we can cancel. So the final answer is 2 pi by 3. Is it clear? Thank you.